It is unlikely that simply changing two of the three-phase conductors will resolve the power issues. The transformer replacement may have caused other problems such as incorrect phase rotation, damaged or loose connections, overloads or short circuits, or harmonic distortion. To troubleshoot the power issues, you should perform the following steps. Firstly, verify the power supply. Ensure that the utility pole transformer is properly connected and providing the correct voltage and frequency. Secondly, inspect electrical equipment. Check the electrical system for any obvious signs of damage or loose connections. Thirdly, test phase rotation. Using a phase rotation tester, verify that the phase rotation is correct at the main distribution panel. Fourthly, check load balance. Measure the current on each phase to ensure that the load is balanced across all three phases. Fifthly, inspect transformers if applicable. If there are any step-down transformers, inspect them for proper operation and connection. Sixthly, analyze power quality. Use a power quality analyzer to detect any power quality issues such as harmonics or voltage sags. Once the root cause of the power issues has been identified, the appropriate corrective actions can be taken. This may involve adjusting phase rotation, repairing or replacing damaged connections, correcting load imbalances, replacing or repairing transformers, or installing power quality mitigation devices. Electrical troubleshooting should only be performed by qualified and licensed electricians. Before proceeding with any work, ensure that all safety precautions are followed and that you have the necessary training and experience. To elaborate, let's dive into each of those steps a little more deeply. Verifying the power supply is crucial. You need to confirm that the replacement transformer is correctly sized and configured for the restaurant's electrical load. Use a voltmeter to measure the voltage at the main disconnect. You should find the expected voltage for the service, typically 208 volts or 480 volts, depending on the system. Also, use an ammeter to check the current draw on each phase. This will give you a preliminary indication of whether the load is balanced. Check the frequency of the power supply with a frequency meter. It should be at 60 Hz. Next, in the process of inspecting the electrical equipment, pay close attention to the main disconnect, the distribution panels, and any subpanels. Look for signs of overheating, such as discoloration or melted insulation. Tighten any loose connections that you find. Use a thermal camera to scan for hot spots, which can indicate loose connections or overloaded circuits. Check the grounding system to ensure that it is intact and properly connected. Look for any signs of corrosion or damage to the grounding conductors. Moving on to testing the phase rotation. A phase rotation tester is an essential tool for this step. Connect the tester to the three-phase conductors at the main distribution panel. The tester will indicate whether the phase rotation is correct, which is typically a BC. If the phase rotation is incorrect, the motors and other three-phase equipment will not operate properly, and it needs to be corrected by swapping two of the phase conductors at the transformer or the main disconnect. Now, to look into checking the load balance. Unbalanced loads can cause a variety of problems, including overheating, voltage drops, and reduced equipment life. Use an ammeter to measure the current on each phase at the main distribution panel. Compare the current readings on the three phases. Ideally, the load should be balanced within 10%. If the load is significantly unbalanced, try to redistribute the loads to balance them more evenly. Check the nameplate ratings of the equipment to ensure that they are not being overloaded. As for inspecting transformers, if there are step-down transformers, check the input and output voltages to ensure that they are within the proper range. Listen for any unusual noises, such as humming or buzzing, which can indicate a problem with the transformer. Check the transformer oil level, if applicable, and look for any signs of leaks. Inspect the transformer windings for signs of overheating or damage. Also, with analyzing power quality, a power quality analyzer can provide a wealth of information about the electrical system. Connect the analyzer to the main distribution panel. Monitor the voltage and current waveforms for any signs of distortion. Check for harmonics, which are multiples of the fundamental frequency. Harmonics can cause a variety of problems, including overheating, equipment malfunction, and increased energy costs. Check for voltage sags and swells, which can damage sensitive electronic equipment. Review the power quality analysis data to identify any other power quality issues. Furthermore, adjusting phase rotation, repairing or replacing damaged connections, correcting load imbalances, replacing or repairing transformers, and installing power quality mitigation devices are all ways to address the problems that have been found. Adjusting the phase rotation involves swapping two of the phase conductors at the transformer or main disconnect. Repairing or replacing damaged connections involves tightening any loose connections that you find. Correcting load imbalances involves redistributing the loads to balance them more evenly. Replacing or repairing transformers involves replacing or repairing any transformers that are found to be defective. Installing power quality mitigation devices involves installing devices such as harmonic filters or surge suppressors to mitigate any power quality issues that are found. Remember that electrical troubleshooting can be dangerous, and it should only be performed by qualified and licensed electricians. Before proceeding with any work, ensure that all safety precautions are followed and that you have the necessary training and experience. Always de-energize the equipment before working on it. Use appropriate personal protective equipment, such as gloves and safety glasses. Follow all applicable electrical codes and regulations. Use properly insulated tools. Be aware of the potential hazards of working with electricity. By following these steps, you should be able to troubleshoot the power issues and restore power to the restaurant. Ensure that all work is compliant with the National Electrical Code, also known as NEC. Some relevant articles to be aware of are Article 220 for branch circuit, feeder, and service calculations, Article 250 for grounding and bonding, Article 310 for conductors for general wiring, Article 408 for switchboards and panel boards, and Article 450 for transformers. When verifying the power supply, ensure that the voltage is within acceptable limits, typically plus or minus 5% of the nominal voltage. For a 208-volt system, the voltage should be between 197.6 volts and 218.4 volts. For a 480-volt system, the voltage should be between 456 volts and 504 volts. Refer to NEC section 210.19 for conductor sizing and overcurrent protection requirements for branch circuits. Refer to NEC section 215.2 for feeder conductor sizing and overcurrent protection requirements. Refer to NEC section 230 for service entrance requirements. When inspecting electrical equipment, look for any signs of water damage or corrosion, which can indicate a potential safety hazard. Check the condition of the conduit and wiring to ensure that they are in good repair. Make sure that all electrical boxes are properly grounded. Refer to NEC section 110.3b for examination, installation, and use of equipment. Refer to NEC section 250.24 for grounding requirements for separately derived systems. Refer to NEC section 300 for wiring methods. When testing phase rotation, be sure to use a phase rotation tester that is designed for the voltage level of the system being tested. Follow the manufacturer's instructions for the proper use of the tester. Incorrect phase rotation can cause serious damage to three-phase equipment. Refer to NEC section 430.8 for motor circuit protection requirements. Refer to NEC section 430.52 for motor overcurrent protection. Refer to NEC section 430.110 for disconnecting means for motors. When checking load balance, use a clamp-on ammeter to measure the current on each phase. This type of ammeter does not require you to disconnect the conductors. If the load is significantly imbalanced, consider using a load balancing transformer to improve the balance. Refer to NEC section 220.42 for general lighting load calculation. Refer to NEC section 220.51 for optional feeder and service load calculations. Refer to NEC section 220.87 for determining existing loads. When inspecting transformers, check the transformer nameplate for the voltage, frequency, and kilovolt-ampere rating. Make sure that the transformer is properly ventilated to prevent overheating. If the transformer is oil-filled, check the oil level and condition. Refer to NEC section 450.3 for transformer overcurrent protection. Refer to NEC section 450.13 for transformer secondary ties. Refer to NEC section 450.21 for transformer location. When analyzing power quality, use a power quality analyzer that is capable of measuring harmonics, voltage sags, and swells. Monitor the power quality over a period of time to get a good understanding of the system's performance. Consider using a power quality mitigation device, such as a harmonic filter or surge suppressor, to improve the power quality. Refer to IEE 519 for harmonic control in electrical power systems. Refer to NEC section 110.9 for interrupting rating. Refer to NEC section 110.10 for fault current protection. When adjusting phase rotation, be sure to energize the circuit before swapping any conductors. Use properly insulated tools to avoid electrical shock. Double-check the phase rotation after making the changes to ensure that it is correct. When repairing or replacing damaged connections, use the proper crimping tools and connectors to ensure a good connection. Tighten all connections to the proper torque. Inspect the connections after they have been tightened to ensure that they are secure. Refer to NEC section 110.14 for electrical connections. Refer to NEC section 250.8 for connection of grounding and bonding equipment. Refer to NEC section 314.16 for number of conductors in outlet device and junction boxes and conduit bodies. When correcting load imbalances, try to redistribute the loads to balance them more evenly. This may involve moving circuits to different panels while adding new circuits. Be sure to follow all applicable electrical codes and regulations when making changes to the electrical system. When replacing or repairing transformers, be sure to use a transformer that is properly sized for the load. Follow the manufacturer's instructions for installation and maintenance. Dispose of the old transformer properly. When installing power quality mitigation devices, be sure to follow the manufacturer's instructions. Select a device that is appropriate for the type of power quality issue being addressed. Consider consulting with a power quality expert to determine the best solution. Remember that electrical troubleshooting can be dangerous, and it should only be performed by qualified and licensed electricians. Before proceeding with any work, ensure that all safety precautions are followed and that you have the necessary training and experience. Always to energize the equipment before working on it. Use appropriate personal protective equipment, such as gloves and safety glasses. Follow all applicable electrical codes and regulations. Use properly insulated tools. Be aware of the potential hazards of working with electricity. Let's also consider the practical aspects of troubleshooting in a restaurant environment. Restaurants often have demanding operational schedules. Coordinate with the restaurant management to schedule the troubleshooting and repair work during off-peak hours to minimize disruption. Restaurants are sensitive to food safety and hygiene. Take precautions to avoid contaminating food or work areas with dust, debris, or tools. Restaurants often have complex electrical systems that power a variety of equipment, including lighting, refrigeration, cooking equipment, and point-of-sale systems. Be prepared to troubleshoot a wide range of electrical issues. Many restaurants have backup generators to provide power during outages. If the restaurant has a generator, be sure to test it to ensure that it is functioning properly. Restaurants may have energy management systems to control lighting, heating, and cooling. Be familiar with the operation of these systems, and be aware of any specific safety regulations that apply to restaurant environments. These might include fire safety, food safety, and employee safety regulations. Document all of your work, including the steps you took to troubleshoot the problem, the results of your tests, and the corrective actions that you took. Keep accurate records of the equipment that you inspect and maintain. Provide the restaurant management with a written report of your findings and recommendations. This report should include a clear explanation of the problem, the steps you took to resolve it, and any recommendations for preventing future problems. Also, be sure to maintain open communication with the restaurant management throughout the troubleshooting and repair process. Keep them informed of your progress and any potential delays. Answer their questions and address their concerns. By following these tips, you can troubleshoot electrical problems in a restaurant efficiently and effectively while minimizing disruption to the restaurant's operations. If you are unsure about any aspect of the troubleshooting process, consult with a qualified electrical engineer or other expert. Consider using specialized diagnostic tools such as a thermal imaging camera or a power quality analyzer. These tools can help you to quickly and accurately identify electrical problems. Also, be aware of any local codes or regulations that may apply to electrical work in restaurants. Work with the restaurant management to develop a plan for preventing future electrical problems. This plan should include regular inspections, maintenance, and testing of the electrical system. This will help to ensure the safety of the restaurant's employees and customers, and it will also help to prevent costly repairs.